Hi everyone, Roman Kozak here. Welcome to part 1 of a 3-part tutorial series on how to design a printed circuit board in Altium Designer. Altium is the world's most popular PCB design software, and it's used at companies like Boeing and top institutions where engineering is taught. In the first part of this series, we'll be selecting components and creating the schematic. So we'll be creating these 2 schematic sheets. In the second part of this series, we will be placing the components onto the PCB here, as well as routing the connections between them. In the third part and final part, we will be creating the manufacturing files and sending it off to the Chinese manufacturer PCBWay for manufacturing. And then we'll get it in the mail, and then we can solder the components on there and have it be a functional PCB. So to introduce the project, we'll be designing this portable battery charger. It has 2 USB Type-C ports, one for charging the internal battery, and then the other one for charging your smartphone. And that internal battery is connected here with this JTAG connector. And there are 2 main components to this circuit. And I've separated those 2 main components in these 2 schematic sheets, which is quite common. So in the first component, we will be charging the battery with this lithium-ion, lithium polymer battery charger integrated circuit. And we have its data sheet right here. The second component to this circuit is the DC to DC step-up converter, which takes the power from that battery and steps it up to a stable 5 volts so that it can charge your phone. And we can see that integrated circuit right here. Step-up DC to DC converter. Okay, let's get started. So I'm going to go to File, New, Project, and I'm going to select to save it in Altium 365. Now, Altium 365 is Altium's web viewer where you can easily share your projects and others can view all your project files, your bill of materials. They can view your board in 3D, etc. And it's a great place as well to do version control for your project. So as you can see here are all my commits. So you can think of Altium 365 as a web viewer on steroids for your Altium projects, and it's quite useful. And you can see here, you can get others to place comments, etc. So yes, I'll be saving it to Altium 365, and let's name this USB-C charger. And we're just gonna add a little description here. We'll say 2000 milliamp hour internal battery and 1 amp 5 volt output. Great. Okay, and we'll start by just adding the necessary documents to our project. So I'll go Add New to Project, and I'm going to add a schematic sheet, and we'll rename this schematic sheet to Charge Controller. Click Save, and that's going to be our first schematic sheet, which will house the charge controller integrated circuit as well as its supporting passives. We'll add another schematic, and we will rename this to DC to DC converter. So click Save. We're also going to add the PCB file. So this is where you'll be doing all the work to lay out your PCB in video number 2. So we'll name this to the project title, USB-C charger. Click Save. And finally, we're going to add a bill of materials document. And the cool thing about Altium is this is a smart bill of materials that can monitor to make sure that these components are going to stay in stock. But more on that later. So let's click on this first sheet called Charge Controller. First thing we're going to do is just make sure that your grid here in Schematic is set to these presets. So 10 mil, 50 mil, and 100 mil. And you can see if I click the G key, my grid size changes from 1050 to 100. So we're going to keep it on 100 for right now. Make sure that your sheet here is set to sheet size A, landscape, and standard title block. And you know what, we can go ahead and give it a title as well. So we will call this Charge Controller. That way if we ever share our schematic with someone, they just have a bit more information. Okay, now let's begin laying out our components. I'm not going to go into detail exactly how I selected each specific component. You can learn that in a circuit design class. Today we're just learning how to lay out your schematic in Altium. So that's called schematic capture. But to give you a quick idea, if we look in the datasheet of this integrated circuit, it has a typical application schematic. So you'll notice that the first schematic sheet, the schematic's going to look a lot like this. And in our second schematic sheet with the DC to DC step-up converter, our schematic is going to look a lot like this application circuit. So let's start by laying out these two resistors here that we see. Okay, and these are the same resistors here. So we have a 1K resistor and a 2K resistor. Let's go find those. To do that, go to Panels and click Manufacturer Part Search. And we will clear what we previously searched here. Okay, so type resistor 1K as well as the package size 0805 and click Enter. Now here we can see all of the resistors that exist on suppliers like Altium, suppliers like DigiKey, Mouser, Arrow, etc. So all of these are available components that we can use. Now something I like to do is just ensure that the component has a 3D model. This way we won't have to design these 3D models, and it will look nice when we take a look at it in the 3D view. Okay, so let's just select a resistor. I like this manufacturer, but I mean, you could select any resistor here and it should be fine. And we can see that there are a lot in stock here. There are 18 million of these resistors in stock, and this resistor here is incredibly cheap. So it looks like a very good part to select in a circuit that we want to not have supply issues. If you want to compare two components, hold down the Shift key as you select those two components, and then you can see they are compared side by side here. Okay, so let's go back to this one that had the 18 million in stock, and we can simply drag it onto our schematic here, like that. Now, if you'll remember, that second part that we were going to place was the 2K resistor. So we just enter resistor 2K as well as the package size 0805. I can see here that this manufacturer also has a 2K resistor with almost 3 million in stock. So that looks good. You can see it's 2K, surface mount 0805, looks perfect. We're going to drag it on. And just a note here, if you click the Shift key, you'll be able to rotate it just like that. Okay, so let's get these in the general location that we want them. So horizontal in the left-hand side, and we can see vertical on the right. So we'll drag this one over here, horizontal on the left, vertical on the right. We're also going to give this resistor a comment that has its value, so 2K. And we'll give this resistor a comment that has its value at 1K. Okay. There we go. That looks good. Okay, value 2K, value 1K. Now, you can see here, you can see that the supplier information is here. And if you click on it, you'll be able to access the data sheet. And we have other properties here as well. So Altium is really good at carrying that data forward throughout your design. And we'll just go ahead and name this resistor to what it is named here. So R1 as well as R2. So R1 and R2. Okay, now let's place these two capacitors. So I can see here that this is a multi-layer ceramic capacitor that has package size 0805. So let's go find that through the manufacturer part search. So we can type and this has a value of 4.7 microfarads. Okay, and once again, we'll select only ones that have models. Okay, and here I can see a ceramic multi-layer capacitor with a good voltage rating, so greater than it's going to experience in our circuit, 4.7 microfarads, perfect. So I will take this capacitor and I will drag it into my schematic, clicking the space button to make it vertical. And let's see if I need multiple of those. So I do need 2 of those. And the way I can do that is just by right-clicking, copy, and then right-click, paste. Okay. And once again, let's name these C2 as well as C1 respectively. So we will name this here C2, and we'll give it a comment of 4.7 microfarads. There we go. Now let's see what else we need to place. So we need to place this LED. And if I click on this LED, we can see that it's red. So let's go find that. Through manufacturer part search. And I can simply enter LED red, again with package size 0805. Here we go. I have a red LED that is size 0805, and there are 105,000 in stock. Once again, here are the distributor informations. So I'm going to drag this one into my project. And it has the designator LED1. Okay, so let's name it LED1. And this is going to be a charging indicator. So I've just titled it such. Okay, we also need to place this switch. So we will go and find that. Panels, manufacturer part search. And I'm just going to get the exact model number of this switch here. So I can see manufacturer part number, copy. Now, you could, if you didn't know what switch you wanted to use yet, you could simply enter in switch here, and you'd be able to select one of the many switches. But in order to save time, I've already selected one, which is right here, that I know works and is in stock, so that's the one we're going to use. So let's drag it into our project. We also have this JST battery connector that's going to connect to our lithium polymer battery. So we will grab that. And I know the model number of this connector, so it's S2B-PH-K-S. Okay, here it is. We'll drag it into my project. Now, it looks like we have placed all of the components here that support our integrated circuit, and we will need to place our integrated circuit in 1 second. But before we do that, we're gonna get these final 2 resistors down here, as well as the USB Type-C input. So these are 56K resistors. We will go grab those. So once again, resistor 56K, 0805. There we go, has model. They're 80K in stock, 10 cents. Looks good to me. We will place it, and then we'll copy and paste it. And we'll move them down into the general direction. And finally, we have, well, I guess second last part in this sheet is the USB Type-C charger. And I am also just going to go over here and get that manufacturer part number. Okay, so it's right here. Hopefully this works. So we should just be able to enter in that part number here. There we go. Here's that USB Type-C connector. You'll notice this is quite pricey. It's $3.76. But this connector is nice because it has the 3D model associated with it right here. Right? You'll be able to find some cheaper components, but they don't necessarily have the 3D model here, and you'd have to go and design that 3D model if you wanted to see it in the 3D view. Okay, so let's drag that USB Type-C connector here and place it. Okay, now the final thing that we have to place is this part right here. So we can grab its part number, go into the manufacturer part search, and we are specifically looking for this component here. Now, you will see it doesn't have a complete 3D model. It looks like only the pads exist on this 3D model. So I'm going to go ahead and actually custom design this part to show you how to make a part if that part doesn't exist in the manufacturer part search. So once again, the reason I'm going to custom design this is just because it doesn't have a 3D view. And I'll find one that does have a 3D view. So you can see here, this one has a full 3D view with its complete package. Now it's quite easy to make. So you'll want to create a library. So the way you do that is you go to File, New, library, and we'll create a schematic library. Okay, and we're going to name this component by its part number. So here's its part number. Okay, so right here on the right, we'll name it by its part number. And integrated circuits have the designator U. Okay, and we can quickly give it a description. So you would be designing this part custom if it didn't exist in the, if a schematic symbol or the 3D model did not exist in the manufacturer part search, which often happens. Most components you'll use will exist with schematic symbols and the model in the manufacturer part search, but if it doesn't, this is what you'll have to do. Okay, so we're going to create the symbol. So what we're creating is this guy right here, the physical symbol that you see in the schematic sheet. And while we're here, we'll just rename our custom library to maybe custom lib and click save. And make sure that your grid is again on 100 mils. And we'll start by placing a rectangle. So I'm going to place this rectangle at coordinates -400 mil and -300 mil. Sorry, let me just drag that up. Okay. So this rectangle you see here is 600 mils high by 800 mils wide. And we can go ahead and start placing pins. So we're going to use this data sheet here as reference. And you can see that this part here has 5 pins, 1, 2, 3, 4, 5. So we're going to place those 5 pins. 2 on the left, 3 on the right. So we'll use this. And again, you can use a space key to rotate. Where you see the crosshairs has to be on the outer side of the symbol. So we will place 1, 2, 3, 4, 5. There we go. Now you can see here, they are numbered 1, 2, 3, 4, 5. Now we have to continue with that numbering. So this is going to have designator 1, and its name is VN. There we go, designator 1 VN, just like it is here in the datasheet. This pin here will have designator 4 with name. Sorry, if we, it looks like that bottom one is stat. Okay, my bad. Stat. This one here is V1. Sorry, VN. Okay, and then here we have VBAT. With designator 3. And then we have designator 5 with name PROG for program. And then finally, we have name VSS with designator 2. Now, we'll quickly just set the electrical type. So VN is power, stat is an output, VBAT is power, program is an input, and VSS again is power. Okay, and we can click File and Save here. So we are done with the schematic symbol, but now we have to create the footprint that the component itself is going to sit on the circuit board. So you can see here, this gold, the copper here is what we need to create next. So let's go back in to our libraries folder here, and let's go File, New, Library, PCB library. Okay. Now, you could go ahead and use pads to, create this component, but we're going to do something that's a lot easier. We're going to go into Tools and IPC Compliant Footprint Wizard. So this will make it very easy to create that footprint. Now, let's see. We will be using the small outline transistor, so the SOT23 package type with 5 pins. So let's go and find that here. So we can see SOT23. We'll click Next. So ours has 5 leads, and we need to enter in the package overall dimensions, which can also be found here in the data sheet. So let's scroll down until we find it. Okay, we're close. Here it is. Okay, so let's see what we need first. We need the body width range, E1. So we can see E1 is the width of the body. Now let's find E1 and just confirm it is the same thing. So there we go, E1, yes, it is the width of the body. Okay, and that there is 1.6 millimeters. So 1.6 millimeters, good. D, what's D here? D is 2.9. Let's look at 2.9, good. A is maximum height, 1.75. A, overall height, 1.45, good. And minimum standoff height, A1. Which if we go up here, we can see A1. That is 0.15. Okay, good. So we can click Next. And now with the copper pieces themselves, so what we just entered the dimensions in for was this right here, to design the 3D view. Now we're entering the dimensions to design the copper. So the lead width range, and this should just be a page down. Here we go. So B looks like it's X here, so 0.6. Let's take a little closer look. Okay, we're still using these dimensions actually. Okay, 0.2 and 0.51. 0.2, 0.51, good, good, good. And if you continue through with this, you'll realize that the rest of these are the same as they are in the datasheet. So we can just click Next, 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 medium, board density, Next. Okay. And we'll use the suggested values, and we'll add it to the current PCB lib file. Okay. Click Finish. And you can see here is this footprint that we just designed very quickly using the footprint wizard. And we're just going to go ahead and save this PCB library file. And I just want to remember what I saved. Okay, we saved it as custom lib. So I can go and save this as custom lib as well. Okay, click save. Perfect. Now we're going to go back into our project here. And we're going to go to panels and components. And click here on operations, file-based library preferences. I'm just going to remove this one, remove that one. Okay. I'm going to go to install, and we're going to install those two libraries that we just created. So I'll go to where I saved them. Now I forget where I saved them, so let's just go take a quick look. Where I saved them, file, save as. Or you know what, to make it simpler, I'm just going to save it onto my desktop. There we go, save. And again, I'll save this onto my desktop. Okay, save. Now we can go back into our project and add the library to our project. So here in the desktop, we'll select both libraries that we just made. And now they are installed. Now we have to link these pins on the schematic symbol to these pins here on the PCB footprint. So the way to do that is to go and click add footprint on this part here. So make sure that the part's selected and then click add footprint. And we're going to browse and we're going to select our custom library here. Click OK, OK. And there we go. Now the footprint is linked to the schematic symbol. Now, the last thing we're going to do is we're going to add some parameters here. So we're going to add supplier links, its manufacturer part number to these parameters here. So to do that, go to the manufacturer part search and we're going to enter in the model number. And all this is going to do is, once again, search DigiKey Mouser for this component and grab its information. So we found the part that we want here, and we're just going to right click and click add supplier links and parameter to that component we just made. Okay. And then I can exit out. And now you can see here the parameters field is populated with even things like the data sheet, as well as all the other information. So this is a custom component that we just made. Okay. And I'm gonna hide that. Save it. And then we can go back to our schematic and place this part. So to place this part, go into components and go to that library that we just made and that part we just made in that library, and then you can drag it over just like that, okay? Now, before we connect these components together, we're going to go ahead and place the components we need for the second schematic sheet. So I just showed you how to place components. So I'm going to do the exact same process for this second schematic sheet, but it's just going to fast forward, so you don't need to watch everything again. There is nothing special about this, about the way that I'm placing the second, the components on the second schematic sheet here. So I'll start by placing the resistors. Okay, so I've placed all the resistors. The next thing I'm going to do is place the capacitors. So here I have a multi-layer ceramic capacitor, 22 microfarad, as well as another 22 microfarad capacitor. So let's go find those two. Panels, manufacturer part search. I'm going to go ahead and change the value to 22 microfarad rather than its part number. Okay. And now I'm going to place these two diodes. So I'm going to go to Panels, Manufacturer Part Search, and I can simply enter in diode Now I'm going to search by manufacturer for Vishay. Okay, here we go. I can see there are 562,000 in stock, so that's a good part. But don't want to place on the wrong sheet. We're going to go back here. 1, 2, move this capacitor over. Go. Okay, what else do we have to lay out? We've done the diodes, the capacitors, the resistors. Okay, it looks like we just have the inductor left over and the LED. So let's grab the inductor. So here we're going to enter in and we'll set the manufacturer to Murata. We'll filter by inductance. Now let's see if they have a 22 microhenry, a 2.2 microhenry inductor. There we go, they do. And let's go to size. And let's select size 1008. Okay. Yeah, this is the inductor I want to use. There are a good number in stock. It has both the schematic symbol and the 3D model as well, so we'll just drag that in. Okay. And then we need that LED as well. So it's going to be a blue LED. And we'll just clear some of the filters here really quick. Okay. So LED blue 0805. Perfect. So here we go, a blue LED, size 0805, cheap and a lot in stock. So that's the one we'll do. Okay. And I know that we need the USB Type-C port. So you know what I'm going to do? I'm just going to grab it from the previous schematic here. We'll just right-click, copy, bring it into this schematic here, paste. Okay, let's see what else we need to place. So we have the LEDs, the resistors, the capacitors, the inductors. Okay, we're all good. The only thing left to do is find this integrated circuit here. So I have the data sheet here. So I can copy and paste its part number, go into the manufacturer part search, okay, and then enter it into the manufacturer part search and click enter. So I can see that it came up here. There are 39,000 in stock. It's about $1. It's the exact part I'm looking for, but it doesn't have a schematic symbol or a footprint. So in order to use this part and have it in the schematic, we need a schematic symbol and footprint for it. So just like we did with that battery charger, we're also going to have to make this custom symbol and footprint in our library. So we're going to go to our custom library here. We're going to add another part. We'll call it by the part number. And then again, we will create the body of the part here. So just generally place that. Okay, and I'm going to make it 1,000 mils tall, so that'll be 5 up on this side and 5 down on that side. We'll make it a little bit wider. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 times 100 mil grid there, it's 1,000 mils. Okay, now let's go see what pins we need to place. So if I go down here into the application schematic, I can see that we need to place these pins here. So we have VN, PG, EN, so we'll place these now. Okay, and then we'll use the pin labeling here. 1, 2, 3, so 1 for LX, 2 for enable, etc. So let's go click pin, make sure that the crosshairs are on the outside. We'll place 1 there. 2 at the bottom, and then 5 here. So 1, 2, 3, 4, 5. Perfect spacing. And we'll actually just space these out. Okay. So this first pin here will have designator 3 and will be called VN. Second pin here will have designator 2 and be called enable. Third pin here will have designator 6 and will be called RSET. LX, 1, LX. So, Perfect. Okay, so we have officially created the schematic symbol. We can click File, Save. You know what? Let's give it a quick description while we're here. We'll just copy and paste the quick datasheet description. Here we go, paste. And once again, we'll give it a designator of view, question mark. Okay. That looks good. And you can see here there's no footprint currently associated with it. It says footprint is missing. So we're going to go ahead and create that footprint now. We'll go back to projects. We'll go to our custom footprint library. See, we only have one footprint in here now. So we're going to have to add another footprint. So you can either click this add button and then, you know, place the pads as such and create the custom footprint. But you know, that takes a lot of time. So what we're going to do instead is we're going to use that IPC compliant footprint wizard. Okay, so let's go into our data sheet and find the specifications for the package size and the footprint size for this part. So we will be using the mini SOP package here with 8 leads. And if I go down a little bit further, it looks like I missed it. Oh, here we go. Here's the data we will need. So I click next. So we have SOP, small outline package. We'll click next. And we'll just make sure that this data here is matching this data here. So I'm going to go ahead and do that, and I'll let you know when I'm done. Okay, all of these package dimensions are now accurate. We're not going to add a thermal pad. Okay, next, we'll add it to our current PCB library, custom lib. There we go, finish. And here's our new footprint. So we'll just make sure to save this library and then go back into our projects. We'll click on the schematic library, and we're going to go here and we're going to click add footprint, browse our custom library, and here is that footprint that we just made. Okay, click OK, and you can see they're linked together now. And if I click File, Save, you can see that they're linked. Perfect. Okay. And also you can see here in the footprint that the pins are labeled 1, 2, 3, 4, and those correspond to the same pins that you see here. So 1, 2, 3, 4. So if we just give it a quick check, LX pin 1 is right here. So that means pin 1 on the footprint should be LX. So let's go verify that quickly. LX pin 1 is right there. So we can see here it's right by the indicator on the package that it's LX, so that we know we designed it correctly. So File, Save. And now we can finally place this part into our schematic by going to Components, and we can see it pop up here. So we'll drag it over. There we go, drag it over. Okay, finally, we have all of the parts that we will need in the entirety of this project. Every component that's required to build this portable battery charger is now placed. Now we can go ahead and start wiring them together per se. So let's go ahead and do that. We're going to just, again, make sure that the components are in the approximate right location for wiring them together, as well as that they have the correct designators. So we have R1, R2, LED1. So everything except for the switch has a designator. So we click on the switch here, go to Properties, switch 1, and we can give it a comment. Power, since it's the power switch. Connectors are have the prefixes J, so we'll call this J1, and we can give it the comment that. Okay. So let's see. Now, this might also be a good time to save all of our files. So we'll go to Save All. Or maybe let's not do Save All. Right-click here and click Save. We'll call it USB Charger. Click Save. Now, when we click this Save to Server button, it's going to push all of our new modifications to Altium 365, which is that web viewer. So we can go and type all components added to Schematic. Okay, and click OK. And now this is going to commit this to the Altium 365. And we should be able to, if we refresh the page here, see our project pop up. Okay, here's our project, USB-C charger. So if we double click on it, we will be able to take a look inside. And you can see we've placed all these components. We can see that we have the 2 schematic sheets as well as the PCB file here. And if I go to history, we hopefully can see our first commit. So we have our commit for when the project was created, and then we have the commit for when all of these components were added as well as when these files were made. Perfect. Okay, so we can begin by wiring these parts together. Now the way you do that is by going up here and clicking Place Wire. And we can see that the first connection that we have to make, and we'll start with the simple ones first, but we are going to connect VSS to ground. So we're going to go up here and we're going to place a ground port. And you can see there are multiple different ports. There's a power port, 5 volts, and a ground port. So we're just going to go ahead and place one of these ground ports. Move those out of the way. And then we should be able to take a wire and connect pin VSS to ground. So there we go, pin VSS is connected to ground. Okay, and we're gonna make sure that this is called U1, and let's just see if it's the same naming convention I've used here. Yes, U1. Perfect. Okay. Now the second, we're going to attach this, we're going to attach R2, which is 2K, to ground as well. So we'll get another ground port. And now we can wire PROG through the 2K resistor in series to ground. Let's see what else we have to do. It looks like we have to connect VBAT through the switch to the battery connector. Okay, let's do that. So we're going to take a wire, we're going to connect VBAT to the switch, and then we're going to connect the switch to the power connector. And we're going to add another ground port here because I know that we have to connect the battery to ground, and we're going to connect this capacitor here. And this capacitor is going to ensure that we have a nice clean signal coming off of the VBAT pin here, so that there are no issues on the USB Type-C output. So we're just connecting that capacitor again in series to ground. Okay, let's see if there's anything else we need to do on the right-hand side here. No, so we have 4 ground ports. Okay, now on this right side, we can connect R1 with the LED to the stat pin, and then, yeah, so we'll do that first. Okay, so we'll move these 2 components just a little bit closer, and we'll use a wire to go from the stat pin to the LED, connect the LED to the 1K resistor, and now we're going to connect V in. Here we go. And we're just going to extend V in with a wire. Now I'm going to assign a net name to V in. So to do that, right click here and select net label. And again, I'm going to click the space key so that my crosshairs, oh no, it's not the space key. I'm going to click tab to pause the current placement, and then I'm going to make the crosshairs go to the left. And while I'm here, I can name this 5 volts VN. So I've just assigned, by placing this net label on this wire here, you can see that this wire now is called 5 volt VN. Now what this means is any other wire that has the name 5 volt VN will be connected, even though they might not physically be connected in the schematic. I'm going to continue wiring some things up. So I know that the LED needs to be connected here. And then that this is an input capacitor that we will connect as such to a ground port. Okay. There we go. So we have this integrated circuit here all wired up, but now we need to connect this USB port to the integrated circuit. This is USB Type-C, so it looks pretty complicated. And there are so many pins because this port here supports video, it supports very high power charging, as well as many other things, including legacy USB, which we will be connecting it to. So we can start first by connecting these pins here to ground. And I'll just quickly explain what I've done here. So we've extended the pins that we want to connect with a wire, and we've assigned a net label to them so that we can name that wire to ground. So for example, this wire here that we've added net label 5 volts into, so 5V in, it's automatically connected to this wire here. And to highlight that, I might be able to double click. Okay, well, yeah, any wire here which has the physical name and net name 5V in are connected. So we'll be connected electrically. So I'm going to now go into our schematic and just break out the pins that we want to connect. Okay. Okay, now that I've broken out those pins, I can now assign net labels to them. So I'm gonna, because 5VN is already typed here, I'm gonna drop this on the V bus. So this is the power pins that are coming off the USB port. And I'm gonna click this, no, I'm not gonna do that. I'm gonna click the tab key, anchor it to the right, and then put this on the V bus on the other side. I'm going to click the tab key again, change this to ground, the net name to ground, and then I can assign the net label ground to the wires that I would like to be connected to ground. Tab key, switch it over to the right, to the left. There we go. And it looks like I missed a couple of the 5V VNs here, so I'm going to select the net label here again. Tab, 5VN, and connect it to VBus. Okay. Now the last two pins that I need are CC1 and CC2, and these are just requirements from the USB Type-C kind of spec that say these must be connected to some resistors, and that allows a USB device to understand a little bit more information about what the application is. So when a USB Type-C port connects here, it might understand that this is a charger. So we're going to just go here, and we're going to change the name to CC1 in. Okay, and we will put the anchor on the left, place it there, tab again, CC2 in, and then we will place it on the wire that we would like to name CC2. Okay, now these resistors just need to be connected in series to CC1 and CC2, and then go to VN. So we'll just really quickly do that. And these here are 56K resistors, and we can just verify that by looking down here, and we can see that's 56,000 ohms, which of course is 56K. Okay, 56. And let's just see what we should set these designators as. So R11 and R14. There we go. And then I'm going to extend these pins using a wire. There we go. And then I'm going to, just like in our reference schematic, connect these pins together. And I'm going to assign a net label here. And this is going to be 5 volt in. Okay, and then we're gonna assign the net labels here, CC1 in, as well as CC2 in, respectively. Okay, and we can take a little look. So if I click on this wire here, you can see it is 5V in. If I click on this wire here, you can see it's labeled CC1 in, as well as CC2 in. So that means CC1 in would be connected here, and CC2 in is connected there. Now, alternatively, I could have just ran a wire like this and connected them, and it has the identical effect. But of course, what we did at first here is a lot neater, so that's why we did it. Okay, so I'm just gonna move this out of the way. And yeah, we can add the text here that says USB Type-C in, USB-C input. And we'll make this slightly larger text. Okay, now the last thing we're gonna do is just place a directive that tells Altium here that we're purposefully not connecting these and not just forgetting them. There we go. Now let's see, is there anything else that I need to connect? It doesn't look like it, so I'm gonna go File, Save. And you know what, I might click Save to Server, and I might say, connected components in charge controller schematic. Okay. Just so that we have that nice history in our version control. So now we're going to go over to our second schematic sheet for the DC to DC converter, and we're going to go ahead and connect these components. So using the exact same method that we did to make this schematic sheet here, we're going to use this schematic here as reference. Now you can see here, this looks quite identical to what we did before. So I can actually copy and paste this here into my sheet. So I'm going to just start by pasting it in. Oh, okay. We should delete this. And then we will drag this over. Okay, there we go. So there is one small difference. Of course, this is going to be an output now. Also, we are going to be using these 4 pins here, DP1, DP2, and these stand for data positive, data negative, and because it's you can reverse the USB Type-C connector, we have 1 and 2 as well. So let's see in our reference schematic what we connected to DP1, DP2. Okay, so we have a net called D+, net name D+, connected to DP1. So let's do that. We're going to get rid of these directives here. So if I just highlight these 4, right click, cut, I can extend these wires. And now I can assign net labels to them. So hit the tab, and we're going to go D+. So we're going to create a new net name called D+. And we will put it on DP1 and DP2. So there's it on DP2. We're going to click tab again, set anchor left, and put this on DP1. Hit tab again, create a new net name called DP negative. Tab again, set anchor right. DP negative 2. Okay. And we do have to set the designator on this USB symbol here. So if you click on the symbol, we can set its designator to J2. Just as it is set in our reference schematic. Okay. And it looks like I just forgot a directive here on the shell, so I'm going to go place directives, no connect. Also here, we'll set the designators. So the designators are going to be R13 and R12. So let's set R13 as well as R12. And we're going to change these net names here. Instead of in, they're going to be out, because this is the USB port that is going to be connected to that's going to be charging your phone. And looks like we forgot an R before there. What about? Okay, and it's giving us an error there with the red squiggly line because we also need to change this net label here to CC1 out and this net label here to CC2 out. There we go. And that error is gone. Okay, so now we can go ahead and wire up these components using our reference schematic. Oh, and one other thing that I did notice here, so we have it connected to positive 5 volts instead of VN, and we also have to make that change here as well. So now the USB connector here is not connected to 5 VN, it's actually going to be connected to 5 volts. So we can go type 5 volts there. Okay. So we'll change that to 5 volts. Just because 5 volts is our nice regulated 5 volt output, that comes after our DC to DC step-up converter, whereas 5 volts in is that input that we use to charge the battery. Okay. Now we can connect these together. So move these a little bit to the right. Move this. Yeah, we'll start by making sure that these components are in the appropriate locations with the proper designators. So here we have the capacitor that's connected to Vin on U2 here is going to be C3, and then the resistor, 750K resistor, is going to be R4. So let's just make sure that this has designator C3. R4. And this is our only inductor, so it's going to be L1. And this inductor here is 2.2 microhenries. Okay. And okay, let's continue on with the components that are surrounding the output of the integrated circuit. So the LED here we have labeled as LED2 and power LED. So let's change that. Okay. And then we have a low voltage divider here that looks like it's going into the feedback pin of the integrated circuit. So in that voltage divider, we have 750K and 100K. So R5 and R3. So there's our 750, here's our 100K. And then we said this one was R5. And this here is R3. Okay. And we have the LED. So next, we have two resistors connected in series, R10 and R8, the 75K and 49.9K. So next we have another 75 and 49K connected in series, R9 and R7. Then we have a filtering capacitor here, C4. And then finally, our two diodes. So we have D2 and D1. Okay, so all the components are placed in their appropriate locations. Now we can go ahead and start wiring them. So let's start with the left-hand side. It looks like we'll start by connecting the inductor. So the inductor is connected from pin 1 to pin 3. Okay, so we'll right-click here, select wire. Connecting the inductor from pin 1 to pin 3. Now it looks like the capacitor as well as the resistor do need to connect to this VIN pin. So this here is VIN. So And I can see that the resistor is connected to the enable pin. And now the capacitor is connected to ground here. So we will first select a ground port, and then we can wire this capacitor to ground. We're not going to connect that reset pin, so we're going to go place directives and a generic non-connect. Okay, so the output here is going to be that 5 volts coming off of the DC to DC step-up converter, and that there is connected to all of these components. So we can just wire them up quickly. So we can start by going like that, just placing wire across, and then connecting each component up to the out. Okay. Now, this here is 5 volts, so we can go ahead and place a 5 volt port on there. And now that what that's going to do is it's going to rename this whole wire here to 5 volts. And yes, you can see there it's going to then also connect anything labeled with a net label 5 volts to here. So these two are connected. Anything with 5 volts or plus 5 volts is connected. Oh, maybe not. They do need to be exactly the same, so we will change that to plus 5 volts. There we go. Now they are all connected. Okay, we can now start wiring the right-hand side. So let's see. We can start with this, with I guess the ground connection here. So we will go and grab by right-clicking. We'll place a ground port to connect A ground and P ground. Now I do know that each one of these also requires a ground port. So I'm just going to grab those. There we go. Now we can wire A ground. There we go. And of course where you see this dot means the two wires are connected. We're going to wire up this voltage divider. It's going back in as feedback to pin FB. We're going to connect the LED here. Oh, that looks like we got the orientation incorrect there on the LED. So I'm just going to delete these two wires and then drag the LED, click the space button to rotate it. And then now the LED is in the right direction. Yes, polarity is important. I think the LED there is the only passive that is polarized currently. Also, I guess, yeah, these diodes would be polarized, but the capacitors in this instance are not. Now, a quick note about these two sets of resistors in series. These are actually resistors that are used to tell the device, the iOS device, so the Apple device that's connected to this USB Type-C port, that it can charge. So Apple devices require resistors, specific resistors on the data pins of the USB port here. So that's why we have these resistors here. So we have to connect them to that USB port. So the way we're going to do that is with a net label here. So we'll give that one D negative. And then we'll click the tab button and name this one D positive. Okay. And you can see if I click on this wire now, that's labeled D negative, and then that's labeled D positive. So that means D positive there will be connected to anything labeled with D positive. So it's connected like that. Okay, and we're just going to really quickly finish the rest of the wiring. So capacitor to ground. So we're finished. We're finished placing all our components and wiring together. But there are just a few more critical things that we have to do before we can move on to the next tutorial, which is placing these components onto the actual circuit board and then routing the copper between them. So we know that net labels such as D minus and D plus are used to connect wires within a schematic sheet. So we know that D negative here, so this wire here, is connected to this wire here because they both have the same net label. But what happens if we want to connect wires across two different schematic sheets? Well, in order to do that, we have to use something called a port. And we want to connect VBAT here, which is the voltage coming off of the battery. We want to connect that to Vin of the DC to DC step-up converter. So we can step up that battery voltage, which is nominally at 3.7 to 4.2 volts, to step it up to 5 volts. So in order to connect these two wires, we'll use a port here. So you can click, select port, hit the tab key on your keyboard, and name this to VBAT and IO unspecified. And then you can just click anywhere on the wire to place it. Then we'll go into our second schematic sheet, the one with the DC to DC converter, and we'll go ahead and add the same port, VBAT unspecified, to Vin on our DC to DC step-up converter. Okay, now these two wires here are connected across sheets. That's pretty awesome. We also want to make sure that when we go and lay out these wires, that the wires carrying power have thicker copper traces than those simply carrying signals. So in order to specify that, we'll use this parameter set here. And I'm going to click the tab icon, or the tab button there, and I'm going to click Add Net Class, and I'm going to change the name of this net class to Power Nets. And then I'll name this Net Class. Okay, now we can click Unpause, and I'm going to select the wires that I want to have thicker copper. So that's going to be these two. It's also going to be the voltage input from the USB. Okay, and that's it. So in the next tutorial, you'll really understand what this means. But for now, we just need to place them. And then we'll go into the second schematic sheet again, and we'll select the parameter set. And you can see here, it carried on and remembered what our previous input was here, but it did not remember the parameter. So we're gonna click Add Net Class. Net class name, we'll change that to Power Nets. Okay. Unpause. We want the battery wire as well as the wire after the inductor to have thicker copper, and we of course want the 5-volt output to have thicker copper. Okay, and that's it for the nets with thicker copper. And just to quickly show you what I mean, I'm going to jump over here to our PCB, and you'll see here in Design under Rules, and if we go to routing and then routing width, we can right here click duplicate rule, and then we're going to rename this rule to power nets. Okay, so if I go here, so I want this rule to be applied to the net class, not all nets. So let's see what happens. Okay. Now the reason why it didn't pop up there is because I did not update this PCB document with our new schematic changes here. So in order to do that, and that's a good next step, I can go to Design, Update PCB Document. And what this is going to do is it's going to push all of the changes that we made in our schematic, and everything that we created in our schematic is going to push that to the PCB. So as you can see, one by one, component by component, wire by wire, those changes are being pushed to the PCB. And if I click close, we can see all of our components now are here on the PCB. And the cool thing is if I click the number 3 on my keyboard, I can actually now see these components in 3D, which is pretty awesome. But more on that in the second tutorial. I'm going to go back to our PCB design rules here and power nets. And this new rule here says anything with the net class power nets, I want to have a thicker trace. So I'm going to say everything with power nets is going to have a minimum copper width of 20 mils. Now, of course, we need to update these as well. So preferred width is 20. And I'm going to say maximum width is 50. Okay. There we go. And now I'm going to click OK. So now, right, any wire here that has the net class power nets, when we go and lay out that copper on our PCB, it's going to make sure and give us an error if that copper is less than the 20 mil or 30 mil width that I set. Okay. Something else that we can do quickly is, add a logo. So we'll go to Place, Drawing Tools, Graphic, and we'll just place logo there, select the logo file, and there we go. You can see that we have a logo now. Just makes it a little bit more professional. We can make stuff look a little bit nicer. We could add notes if we wanted to, just like I have here. So I can copy and paste these over. There we go. And again, I'll just copy and paste over the notes that I also have on this second schematic sheet as well. Copy. But in order for me to place it, I do just need to move that out of the way. And then I can place my notes. We'll give it a quick title, just like we did with that first sheet. We will call it DC to DC Step Up Converter. Well, I'm bad at spelling. Okay. And we will just place our logo again here. let's take a quick look at our bill of materials. So these are all the components that we have placed across our project on these two sheets. And you can access it by clicking the .bom doc, and that's the file that we added earlier by going here and then adding a active BOM. So you might need to click this refresh button here to get all new data and update it with the latest information from the internet, such as a analysis of whether this specific component is suitable for volume production. As you can see, most of ours are suitable for volume production. And also when you click that refresh button, you'll get the updated price as well. So if I click on a component here, you can again, see how many are in stock, what supplier you're getting it from, etc. Now, something cool that I like is you can see here, if I want to make one board, it's going to cost me, $10.57. But what if I wanted to make 1,000 boards? That's going to drop the price down to $742, which is pretty cool. And it's also going to highlight here on the right what parts are not available, in quantity 1,000. You can see it says there's an insufficient stock of these parts. So I would want to go ahead and maybe reselect a component here where there's a higher stock. And that's pretty easy. You can do that by right-clicking here and clicking Add Solution, and then you can go ahead and find different manufacturer links for that. So that's it. That's the active BOM. Something that I do want to point out is our USB Type-C port is quite expensive. You can see it's right here. Every other part that we have on this board is well under $1 at quantity 1,000. But you can see that this USB Type-C port is $3. So what I did over here is I found an alternative cheap USB port. It's only 45 cents compared to $3.33 at quantity 1. So we might want to consider, if we're trying to make a profit by selling these boards, to go ahead and use that cheap USB alternative, because it's pretty clear here that that USB is going to eat well into our profit margins. And just to give you a sense, if I decrease this from $3 for one to 50 cents for one, that means, and because I need 2 of these for board, that means my total board amount is going to go down by $5. So this board could actually be $2.42 if I replace this USB Type-C port with that cheap alternative that I mentioned earlier. Okay, so we now have both of our schematic sheets fully complete. We have all the right net labels, all the right components. Everything is wired together properly. And it looks like we're ready to go ahead and start putting together this PCB. So laying out the components on the PCB, that will be the next step. So I'm just going to commit these final changes, and I'll say completed schematic. And that way we know that this was the point in time that we fully completed the schematic. And that's going to add it to Altium 365, where it'll be in the cloud, safe. And I can go design and just make sure that all final changes here are pushed to the PCB. And okay, we didn't make any final changes, so that's good. And also you can see the green check marks here that signify that this is the all up to date in Altium 365. And you can see here too, we have the 2 schematic sheets here. So the DC to DC converter schematic sheets with all the parts, and then the charge controller schematic sheet with all the parts as well. Now, one cool thing to point out here, you can see all of the nets labeled. So if I double click on +5, you can see all of the wires that are connected together. So everything here is connected together. Of course, ground, everything highlighted is connected together. And of course, that's the same here across sheets. So if I double click on ground, it's also connected. There we go. Okay, well, we are all done with the schematic capture, and we're ready now to start laying out these components and designing our PCB. So thanks so much for sticking around this long, and I look forward to seeing you in the next video.